Hello, students. Have you ever looked around you and wondered, what is everything actually made of? The water you drink, the air you breathe, even the desk you're sitting at? Well, all of it is something we call matter. And today, we're going to explore the fundamental properties of this matter, the tiny secrets that explain everything around us. Okay, so here is our plan for today. We'll start with the basic idea that all matter is made up of particles. Then we will look at the three main characteristics of these particles, one by one. We'll cover the spaces between them, how they are always moving, and finally, how they attract each other. And at the end, we'll summarize everything. Right, so first things first, let's remember this key idea. Everything in the universe is matter, and all this matter is made up of extremely, extremely small particles. Just how small are these particles? Well, they are so small we cannot even imagine it. We cannot see them with our naked eyes. But, and this is the interesting part, we can see their effects through some very simple experiments. So, let's explore the first characteristic, or you can call it the first rule of how these particles behave. And it is this: particles of matter have space between them. Let's think about this. It's a very simple experiment you can do at home. If you dissolve some sugar or even salt in a glass of water, where does the sugar go? It seems to disappear, doesn't it? But the real question is, does the level of water in the glass rise? So let's imagine we are doing this experiment properly. We take a beaker and fill it halfway with water. We very carefully mark the level. Then we add some sugar and stir it well until it completely dissolves. Now, what do we observe when we look at the water level again? And here is the interesting observation. The water level does not change. It stays at the same mark. This shows us something very, very important about the particles of water. So what happened? Well, this happens because the particles of sugar fit into the empty spaces that exist between the water particles. It's a bit like fitting small pebbles into a jar that is already full of large stones. The pebbles just fill the gaps. The sugar particles did the exact same thing. All right, let's move on to the second characteristic. This one is all about movement. The second rule is that particles of matter are continuously moving. They are never, ever still. Think about this common experience. If someone lights an incense stick, an agarbatti, in one corner of a room, you can smell it from far across the room, even if there is no wind blowing. How does the smell travel all the way to you? This is our clue to the second rule. This process, this intermixing of particles of different types of matter, all on their own, has a special name. It is called diffusion. Let's repeat that term because it's important for your exams: diffusion. Now, an interesting question. Does everything diffuse at the same rate? Let's compare. If you put a drop of ink in water, it spreads very quickly. But what about a drop of honey? The honey will diffuse very, very slowly. It might take hours or even days to spread completely. So what gives these particles the ability to move? Well, it's because they possess energy. And the energy that particles have due to their constant motion is called kinetic energy. And this idea of kinetic energy explains something we all know. Why does hot food smell so much stronger from a distance compared to cold food? It's simple. When you increase the temperature, you give the particles more kinetic energy. This makes them move much faster, and so they diffuse much faster. Okay, now for our third and final characteristic. If particles are always moving, why don't things just fall apart? This is because of our third rule. Particles of matter attract each other. Imagine trying to run through this group of dancers holding each other so tightly. It would be very difficult, wouldn't it? This is very similar to the strong force of attraction that exists between particles in a solid. However, and this is a key point, this force of attraction is not the same in all types of matter. Its strength varies, and this variation explains why some things are hard and others are soft. Let's look at this table. It is very, very hard to break an iron nail. Why? Because its particles have a very strong force of attraction holding them together. A piece of chalk, on the other hand, is easier to break. Its particles are held by a less strong force. And a rubber band? Well, that is even weaker. So you see, this force of attraction is what determines the state of matter. Solids are rigid because of very strong attraction. Liquids can flow because the attraction is weaker. And gases spread out because the attraction is very, very weak. Now, please remember this, it is a common point of confusion. Even in gases, there is a force of attraction, but it is extremely weak. All right, so let's quickly recap the three main characteristics we have learned today. These are very important for you to remember. So what are the 3 rules? Number 1, particles of matter have spaces between them. Number 2, particles of matter are continuously moving, which means they have kinetic energy. And number 3, particles of matter attract each other. So now that we know these 3 rules, the question is, how do they work together to create solids, liquids, and gases? Keep this question in your mind, as it is exactly what we will explore in our next chapter, when we study the states of matter and how they can change from one to another.